Hello friends, this video on Sound Part 2 is brought to you by examfear.com. No more fear from exam. Sound waves are longitudinal in nature. So what do I mean by longitudinal? That means the particles of the medium travel parallel to the direction of propagation of wave. So the term longitudinal means that the particles of the medium will travel in a direction parallel to the direction of propagation of wave. So the question, I'm answering this question, right? That what are longitudinal waves? So these are the waves where the particles of the medium, if you look at this figure, what is happening? How is the particle of the medium moving? The particles of the medium are oscillating in this fashion. You concentrate at any of the particles in this picture. Consider this particle or any particle you like. You will see that they are oscillating in this fashion. So the direction in which the particles of the medium are traveling is parallel to the direction of propagation of the wave. So what is the direction of propagation of wave? Wave is nothing but the disturbance. So in which direction is the disturbance traveling? Now do not concentrate on the particles. Now just see the overall picture. How do you feel? Where is the overall disturbance moving? The overall disturbance is actually moving along this direction, right? Because if you see, the disturbance is being transmitted by this 1 to 2 to 3 to 4, like that's what I explained. So the overall that wave is propagating along this direction and the particles are also oscillating along this fashion. That means the particles are oscillating in a direction parallel to the direction of propagation of wave. So such waves are known as longitudinal wave. So sound waves are an example of a longitudinal wave. So sound wave is not the only longitudinal wave. There are many other types of waves which are also longitudinal in nature. So now you understand what is longitudinal? Okay. So similarly, if you take this example also, this also portrays the example of longitudinal wave. Let us suppose if you have a spring, right? Now this spring, if you stretch the spring and leave, what happens? The spring will also oscillate. But in this case, how the oscillation takes place? Some regions the particles are compressed, some regions they are far away, again compressed, again far away, right? So that is how the particles are oscillating, but at the same time if you see how the disturbance is moving, initially the disturbance was here the particles were compressed, after that the particles are compressed in the middle region, after that the particles are compressed here. That means gradually it is moving along this direction, right? So here also the particles are oscillating in a direction parallel to the direction of propagation of the wave. So now when I talk of longitudinal waves, you must be wondering or you must be thinking in your mind that is such a kind of a wave also possible where the particles will oscillate in a direction perpendicular to the direction of propagation of the wave? Yes, that is also possible. So on the basis of this, waves are actually categorized into two types: longitudinal waves and transverse waves. So in longitudinal waves, the particles of the medium oscillate in a direction parallel to the propagation of wave. Whereas in a transverse wave, what happens? The particles oscillate in a direction perpendicular to the direction of propagation of wave. Surprised, right? So let us see how it happens in case of a transverse wave. Let us take the example. So the way sound wave is an example of a longitudinal wave, similarly an example of a transverse wave is a light wave. So what happens in a transverse wave? Let us look at this example. Let us suppose if you have a thin string, a thin wire which is tied at one end to the wall, right? The other end you are holding it. Now let us suppose you slightly move it up and down on one end. What do you see? You see that the entire thing start moving up and down, right? So in this case, each particle of this wire is moving up and down, right? In this direction, up and down, up and down. But gradually this up and down, that means this disturbance. So here, what is my source? Source of the wave is the jerk which I gave with my hand, right? So that was the source. Now this source gave rise to a disturbance in the medium, because of which all the particles started oscillating in this up and down fashion. So that means how is the disturbance getting transmitted? So the disturbance is getting transmitted in this direction. but the particles are oscillating along this direction. So that means here the particles of the medium are oscillating in a direction perpendicular to the direction of the wave. So it is somewhat of this fashion. So if you look at it, the wave as such will move in this direction. The wave as a whole, the disturbance as a whole moves along this direction towards the right. But each particle here keeps moving up and down. So if you look at this blue dot, it represents a particle of the medium. So a particle of the medium is moving up and down, but the wave as such is moving in the horizontal direction. So such waves are known as transverse waves. So example of a transverse wave is light wave. Well, in this lesson we will not go much into detail about transverse waves and longitudinal wave. We will talk about them in class 11th. So for now, I just introduced transverse waves because I spoke about longitudinal wave. So what all did we study about sound so far? Which talked about the production of sound, that the sound is produced by vibrating objects. Then we talked about the propagation of sound, that is sound needs a medium to propagate, and how sound moves through a medium, that also we talked about. The particles of the medium do not move, they just keep oscillating, but the disturbance is transmitted by the vibration of the particles of the medium. We also spoke about the longitudinal nature of sound waves. We also spoke about the fact that sound waves cannot travel in vacuum. Right? So these are some of these things which we got to know so far.
Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.